stick with this constellation. So the energy in symbol I, let's label these S0, S1, S2, S3, S4, S5, S6, S7. Energy in symbol 0, well, what are the coordinates? S, the noise-free filter outputs are alpha I, beta I, which is equal to what? Where does this look? Plus 3, plus 1. So, the energy signal 0 is equal to TS times alpha I squared plus beta I squared, which is equal to TS times, what's 3 squared? 9 plus 1 plus 10 TS. E1, so what's S1? S1 is, the coordinates are plus 1, plus 1. E1 is TS alpha I squared plus beta I squared, which is TS times what? 2. Okay, am I done? I'm basically done. I'm going to say the correct answer is 6 TS. How can I say that?
Just to multiply E0 by 4.
That's right, so there's 4 like this. Those are these corner points. So it's just, all I'm doing here is I'm changing the sign. So this is plus 3 plus 1. This is minus 3 plus 1. That's minus 3 minus 1. That's plus 3 minus 1. So those changes of sign come out under the square. So all of these points have the same energy. There's 4 of those. 4 times 10 is 40 TS. Same thing here. These 4 points, all I'm doing is exchanging sign. So that's plus 1 plus 1. That's minus 1 plus 1. Minus 1 minus 1. Plus 1 minus 1.
That is 16 TS, like energy per bit.
This is energy per symbol.
Oh.
Sorry. 40. So the other one is 8. 4 times 2. 8 TS. And then I divide by 8. 48 TS. Each one has a probability of 8, which is 6 TS. So basically, that's just showing you how to exploit these symmetries, so you don't have to calculate every single one. As long as there's just sign swaps, it comes out under the under the square. Okay, from energy per symbol to energy per bit. What's m here? 8. What's log 2 of 8? Sorry? 3. So energy per bit is 6 TS divided by, for every symbol I'm sending 3 bits, so that's 2 TS. And there's your answer. Any questions on that? So here's an interesting point to note. Say I had a constellation that looks like this. That's plus 1. That's plus 3. Plus 1, plus 3, plus 5, plus 7. said, find the probability of error in that constellation. Do you have to start from scratch? Why? Voronoi regions are all the same. All the distances are the same. These are 2 apart. These are 2 apart, so all the Voronoi regions look the same. So basically, you can completely reuse. Completely reuse everything we did in the example. And in fact, the probability of error is exactly the same because all these Voronoi regions look the same. They have the same shape. They have the same distances. They have all that I'm doing is translating and rotating, and I said that doesn't matter. Now, if I told you to calculate the energy per bit in this signal set, would you say that it's larger or smaller? Larger. Why? That's right. So it's farther. Basically, what I'm looking for is average square distance from the center. So each of these, you can think of each of these points as, firstly, I start with a given vector, and then I start with a given average vector, and then I move to each of these points. So as far as energy is concerned, the smartest thing to do would be to take that average and move it to 0, because every time, if I have a signal constellation like this that has a non-zero average, basically what I'm doing is I'm transmitting some average amount of energy that doesn't do anything. I transmit it with every signal, so it's not information bearing. And then on top of that, I add my signal. So it makes sense to take that useless energy and move it to 0. So in other words, I can take this whole constellation and shift it down here, and it makes absolutely no difference. So the moral of the story is, if you take the average square distance of your entire signal constellation, it should be centered at 0. Otherwise, you're probably sending useless energy. Now, there are reasons to send that useless energy. For instance, if your signal is changing wildly, you might want to send what's called a pilot signal, but that's we're assuming everything is nice and stable, so there's no real reason to send some kind of average offset.
So what would be the easiest way to calculate the energy per symbol for this one?
With this one?
Yeah.
So unfortunately, you can't do this direct. You can't add this. I don't think you can add that average. Does anybody have any ideas if there's a shortcut there other than calculating them all individually? I don't think there's a shortcut here. I think you'd have to calculate it all. But the point is that if you can identify this average, the best thing to do is get rid of it. And this is like a DC component. This is like transmitting some kind of DC signal.